my friends. Today we're talking about the rounding rules for scientific math. And it's important to note that the rounding rules for addition and subtraction are different than the rounding rules for multiplication and division. So let's start with addition and subtraction. So for addition and subtraction, you're going to round to the least amount of significant figures after the decimal. You're going to round to the least amount of significant figures after the decimal. So let's do a sample problem. Let's solve 110.13 plus 10.274. The first thing that we note is that they each have a total of 5 significant figures. But per our rules, it doesn't really matter what the total significant figures are. What matters is the significant figures after the decimal. So let's count this top number. After the decimal, we have 1, 2 significant figures. So let's write that down. After this decimal, we have 1, 2, 3 significant figures. So if the rule is you're rounding to the least significant figures, you have to round to 2 significant figures after the decimal, as that was the least. So when we solve it, it ends up being 120.404 is the total number before rounding. So you can underline how many significant figures you need. We're going to underline that 4 and that 0. And then we're going to look to the right to round. And we're following normal rounding rules. 5 or higher, you round up. 4 or below, you round down. That's below 4, so you leave it as 120.40. Because remember, you have to leave zeros because ending zeros after a decimal are always significant. Okay, let's try another problem. Let's do 297.0006 minus 7.003. So the first thing to note is let's count the total number of significant figures for each of the numbers. For number 1, we have 1, 2, 3, 4, 5, 6, 7 significant figures. And if you're wondering why it's 7, remember zeros between non-zero numbers are always significant. On this one, we have 1, 2, 3, 4, same reason. But remember, for addition and subtraction, we're going to the least amount of significant figures after the decimal. So let's count the significant figures after the decimal. So on this one, we have 1, 2, 3, 4 sig figs. This one we have 1, 2, 3. So based on 4 after decimal and 3 after decimal, we're going to round to 3 as it's the least amount of significant figures. So let's do the math. We have 289.9976. That's before any rounding, but we need 3 significant figures. So we're going to underline the 997 because those are the places we need to represent. Then we're going to look over to the 6 to determine if we're leaving the 7 alone or rounding it up to the 8. The 6 is above 5, so we round the 7 to 8. So we end up with 289.998. That is the final answer for that one. Now let's look at multiplication and division. Because the rule for multiplication and division is you're going to round to the least amount of total sig figs. It doesn't matter before or after decimal, it's rounding to the least amount of total significant figures. So let's try a problem. Okay, let's do 79 times 7. So let's count total sig figs. For 79, it's 2 sig figs, and for 7, it is 1 sig fig. So we have 2 sig figs and 1 sig fig. So we have to round to the least, so we're going to round to 7. So the total amount is 553, but we're rounding to 1 sig fig. So you're going to underline your first sig fig, which is 5, and then you're going to look over to see if you're rounding it up to 6 or leaving it as a 5. It says you're rounding it up to 6 because 5 or higher rounds up. And before you ask, you put zeros in as placeholders because remember, placeholder zeros are not significant, but you have to represent the entire scope of the number. You just can't make it 6 when it's 600. So the answer becomes 600 rounding to 1 sig fig. Let's try one more problem. Okay, let's try 110,967 times 7.94. So the first thing we do is count total numbers of significant figures. So on the top line we have 1, 2, 3, 4, 5 sig figs. On the bottom line we have 3. So what we're going to have to do is round the total number to 3 sig figs because that is the least number of significant figures present in the equation. So we're going to do the entire equation, which is 887,077.98. So we need 3 sig figs. So you're going to underline the first 3 significant figures. That's 8, 7, and 0. With that 0, you're going to look over to the 7 and see if it's higher than 5. If it is, that 0 is going to become 1, and these two 7s are going to become zeros, and you have to drop off any ending zeros because remember, ending zeros become significant. So this is going to become 87,100. Those are some rounding rules. Let's try some practice of our own. Okay, here is problem solver 1. 123.496 plus 4.1234. Go ahead and try and solve rounding to the correct number of significant figures. Okay, let's look at the solution for problem solver 1. Looking at the first line, we have 6 total significant figures, with 3 of those being after the decimal. On the second line, we have 5 total significant figures, with 4 after the decimal. 3 is less than 4, so we're going to round to 3 as it is the least. The total number we get when we add these together is 127.6194. We're looking for just after the decimal now, so we're going to underline the 3 after the decimal that we're looking at. That's 6, 1, and 9. We're going to look over to the 4 and realizes that it's not above 5, so we leave the 9 alone. So our final answer is 127.619. Okay, let's try problem solver 2. Let's multiply 776 by 3. Okay, let's look at the solution for problem solver 2. In 776, you have 3 total significant figures, and 3 has 1 total significant figure. So for multiplication, you're rounding to the least number total significant figures. So the final answer ends up being 2,323. So with us rounding to 1 sig fig, we're going to just underline that first sig fig, which is 2, and look to the right. 3 is under 5, so we're going to leave the 2 alone. So we're going to make that into a 2. And then the 3, 2, 3 become the zeros as placeholders. So you're representing the scope of the number. Thank you so much for learning the rounding rules for scientific math.